Hey guys, look at this, we did it. 1,000 subscribers, finally pushed over the mark. Just want to thank everybody for signing up, and I got a little bonus video for you here, so keep watching. In my previous video I worked on this HP Pavilion laptop, and I'm going to give you a quick review of what we did with that. So first of all, it wasn't powering on, so what I did was I plugged it in. I checked at the DC port here and I found that there was 19 volts here. I then traced that down to here to where there were two vias and then followed that across to the other side of the board. On the other side of the board I followed the 19 volts through these two inductors PL1 and PL2 onto the drain pins of this MOSFET here. This MOSFET had no voltage on the other side, neither on the source pins or on the gate pin. So for some reason the system was choosing not to turn this on, so I suspected that there may be a short somewhere on the system. With my multimeter in diode mode, I took a measurement after the second MOSFET and I found that it measured 0.005 volts, so this indicated a short on the main power rail. My DC power supply, I injected power onto the main voltage rail, starting at 1 volt at half an amp, and I brought it up to 9 volts and 0.8 amps, at which point one section of the board started heating up. When I injected voltage with the power supply set at 9 volts and 0.8 amps, the following IC, which was the battery management IC, started to heat up and basically cook in front of me, as you can see right here. So I chose to remove this IC, and when I did, the short was also removed. Right now you're saying to yourself, why is he telling me all of this again? We went through this last week. Well, there is a purpose to this video. I said last week that I wanted to proceed with working on this laptop without using a schematic, because we need to learn to work without a schematic, because Toshiba's and other models, you just cannot get a schematic. They are useful when we have them, but we don't want to rely on them. So what I did was I proceeded to work my way through where finding the first MOSFET, the second MOSFET and the main power rail. But what I want to do now is I want to get the schematic and compare it to the work that I've done so far and just verify that I'm right. So I know you guys like it when I have them side by side. I have the image on one side and I have the schematic on the other. So we're going to do that now. Okay, so here's my schematic and here's my actual motherboard. So we're starting, of course, at the DC in connector. So this is the DC in connector here. I observed that this was the red wire, so I presumed that this was our positive voltage. It's actually marked PJP1 here, and you can see on our schematic that PJP1 here corresponds to pin 1 and 2, which are joined together, and they go and meet with PL1 and PL2. Now we know that on our actual motherboard this goes down to here and through the vias, and we found these PL1 and PL2 on the other side of the board. So let me flip the board. On the other side of the board, you might remember I tracked the 19 volts across here to these two components, which are PL1 and PL2. So let me just mark that in there. So as you can see, the PL1 corresponds to PL1 here and PL2 corresponds to PL2 here. So we followed that along, and this then becomes V in. This is labeled VN at this point. So we're looking at right here after the two inductors as V in. So let's see where V in is and follow that. I found V in further down in our schematic. You can see it right here. It leads on to PQ101, so that corresponds directly to what I'm seeing on the board here. We've got our inductors. This then is called V in, and VN leads on to PQ101, and it's the same MOSFET here. So we've 6414A, and that corresponds directly to this right here. Now the gate pin of this AON 6414A is controlled by the AC drive pin of our battery management IC. But as you may remember from the previous video, there's 0 volts on this and the MOSFET is not switching on, so our 19 volts gets to here but is not on the other side of the MOSFET. Now when I found that there was 19 volts on the drain pins of this MOSFET but nothing on the other side and nothing on the gate, I diagnosed that there must be an issue somewhere on this motherboard that is causing the battery management IC to pull the gate signal from this and prevent the 19 volts from entering the system. It's not happy for safety reasons to allow that 19 volts in. So my next question was, is there a short somewhere on the motherboard? So I decided to check, first of all, between these two MOSFETs, which is right here and here. I checked this position for a short in diode mode and there was no short here. So I checked then after the second MOSFET, which is this position here, and I found that there was a short in this position. Now, the assumption that I made here was that this point was the main power rail. And if you look at the schematic, you can see this point here is the main power rail. It's just before the current sense resistor. The current sense resistor is actually not visible on this side of the board. It runs the whole way around a big track, and the current sense resistor is actually on the other side of the board. But looking at this, I assumed correctly that this was the main power rail, and I injected in the correct position. Now you may remember I cranked up my DC power supply and I injected 9 volts with 0.8 of an amp, and it's that caused my battery management IC, which is this IC here, to burn up. And this, of course, is the battery management IC that burned up when I injected voltage into the main power rail. So that is my quick review of my work so far alongside the schematic. I think I've done everything pretty okay so far. However, if you wish to disagree with what I've done so far, I would be delighted to hear about it in the comments below. It's an open book here. If you think there's something I could have done better, you're very welcome to put it in the comments down below. And what I'm going to do is I will replace this IC, and if it fixes it, I will post it in another video. I've got a number of laptops coming as well that I'm going to make videos out of. So if you keep on watching, we're all going to keep on learning something, hopefully. And once again, this is your bonus video for the 1000 subscribers. Thanks once again to everybody who signed up, and I'll speak to you soon.